Welcome to Chapter 19 on Turing machines. Now, a Turing machine works a lot like a finite automata, except for we're going to have an input tape. With finite automatas, we just kind of said we had an input word and we read from it. And with this input tape, we're also introducing a tape head that points to the cell that we're currently reading from. So we take our input word and we put it on our input tape. And then it has an infinite number of blanks that go forever in the right direction. And then our Turing machine can move the tape head each time it reads something from this cell. It can make a choice based on what's in that cell. So if there's an A, it can go one way, and if it's a B, it can go another way. And it can also decide whether to move the tape head to the right or move the tape head to the left. Now, in this case, you probably wouldn't want to move your tape head to the left because then it would fall off the edge of the machine, and that means that the machine crashes. And whenever the machine crashes, that means the input word is not a word in the language that the Turing machine defines. So here is an actual Turing machine written down. As you can see, it kind of looks like a finite automata, except for the edges right here have three labels on them instead of just one label on it. So the three labels, the first one is what we're reading. So if there is an A, if we look at our tape head and it's pointing at a cell, if there's an A inside of this cell, then we'd follow this edge. Whereas if there was a B here instead, then we'd follow that edge right there. The second letter is what we want to replace this letter with. So we don't just have to read, we can write it, and we can replace it with different letters. As you can see in this case, we're just replacing it with whatever we read. So when we read an A, we replace it with an A. And finally, the last letter is which way we move the tape head. In this case, we move the tape head to the right. But if we put an L right there, then that means that we'd move our tape head to the left. Now remember, when you move the tape head off to the left, you're going to crash the machine. Now there is another way to crash the machine. If you look in this state right here, if we're reading an A, you see that there is no edge coming out of this that says what to do when you read an A. In that case, the machine also crashes. And then if you notice this accept, or there is no accept, there's just a halt. The only output that this Turing machine really has, besides writing stuff onto the tape, is whether or not it stops. So it could go on and on forever, so an infinite loop, or it can halt, and when it halts, that means the word on the input tape is in the language. So this is kind of like an accept. And then, of course, the machine could crash, and that means the word isn't in the language. So the three options are to halt, and that means the word is in the language. We can the other option is we could go into an infinite loop and never halt, and that means the word is not in the language. And another way to say the word is not in the language is to crash. So the machine crashes either by moving off the left end of the tape or by not having a path to follow, then the word is not in the language. So let's go ahead and run this Turing machine on this input word. And we could see that we're pointing right here, and we see that there's an A. So we're going to move to this state. We're going to write an A back in that state and move our tape head to the right. So you can see the A has been replaced with a new A. Now, it doesn't really change colors or anything. I'm just changing the color so you can see it. And the tape head has also been moved to the right, and now we're in this state. Now, in this next state, when we read a B, we write a B and move the tape head to the right. And now we can see that we're in this state right here, and we're reading an A, which means that both of these are on this label. So no matter what we read, we're just going to write the same thing and move the tape head to the right. And now you can see we're pointing at a cell with a blank in it, which means we're going to take this final edge. When we read a blank, we write a blank back on, and we move the tape head to the right again. Okay, and we land in the halt state so the word is in our language. Now, what does this language accept? Well, it accepts all words where the second letter is a B, because it doesn't matter what the first letter is, as long as it's an A or a B, then the second letter has to be a B. If it's an A, we're going to crash. And then it doesn't matter what the rest of the letters are, it's just going to keep reading until it hits the very first blank. And when it hits the first blank, it's going to move the tape head to the right and halt. So again, this is all words whose second letter is a B. All right, now this is a Turing machine to accept the language A to the N, B to the N. Okay, and I'll show you how it does this in this example right here where we have 3 A's and 3 B's. So the very first step is to move this way, and we're going to read the first A, little a, and turn it into a capital A. Okay, now this is a very important feature of Turing machines. What it's doing here is it's just moving the tape head to the right over all little a's and over all big B's. Now there aren't any big B's in this, but there will be eventually. So basically it says when I read a little a, I write a little a back and I move the tape head to the right. So, and we keep doing that until even past capital B's, which there are none, until we hit our first big B or our first little b right here. When we hit our first little b, we're going to replace it with a capital B and bounce off towards the left. So again, what we do is we pass over all of our little a's. We keep moving our tape head to the right until we find this little b. We find the little b, we replace it with a big B, and we bounce off, and now our tape head's to the left. And now you could see that we're going to pass over any little b's, but there aren't any little b's, so we'll keep going this way. And the next thing we run into is a lowercase a, meaning we're going to follow this path. We don't run into a capital case A. So we run into lowercase a, and we move our tape head to the left, and then we keep moving it to the left until we find our capital A at the beginning. So again, this tape head is going to go here, bounce off of the B's, come back, bounce off of the capital A's, and it's going to kind of keep doing this until it's read all of the letters. So once we hit this capital letter, we're going to move over to the right. So now we're back in the start state. Again, we're moving over all the lowercase letters and moving our tape head to the left until we find our first capital A. Then we replace the capital A and we move our tape head to the right. So it's very important to put markers inside of our string so that we can have our tape head bouncing off of the markers. So now we're back in this state. We're going to change one lowercase a to a capital case A. We're going to move our tape head over all of the lowercase a's and capital B's, change the first lowercase b to capital B, then move our tape head back, bounce off, and then another capital A, another capital B, and we're going to kind of keep doing that. So again, step one, change the lowercase to a capital A, move the tape head to the right past our lowercase b's and capital B's. Then we're going to hit that guy, change him to a capital B. Now we're going to move our tape head over all capital B's and over all lowercase a's, hit this capital A, bounce off of it, and then come right there. And bouncing off of it, we'll be back in this start state and we'll be set to do it again. So we're going to change this to a capital A, move our tape head down until we find the matching lowercase b, change it to a capital B, and then move back. And you can see that after we changed the lowercase b to a capital B, we moved our tape head to the left, and now we're in this state. So this state says keep moving over all of our capital B's until I hit either a lowercase a or a capital A. In this case, I hit a capital A, so that means I'm going to follow this path for the first time, which is good because we matched up all the letters. We just need to check to make sure there aren't any B's on this side of it. So what it's going to do is we're going to move our tape head over all of the B's. So we moved it back to this capital A, and we're going to move it across all the B's, which is this part right here. and make sure that we don't find any lowercase b's. You see there's no edge leaving for a lowercase b there. And that we find a blank after all our capital B's. And if we do that, then we halt and the word is in the language. So that's how this accepts A to the N, B to the N. And hopefully you see the common theme in programming or creating these finite automatas is we're going to put markers on our tape and we're going to move our tape head until we hit a marker or something, bounce off of it and do something else. Now, Alan Turing, who created these Turing machines, thought of this like a whiteboard or a chalkboard. Basically, in order to tell somebody how to prove something, they'd say, okay, you move to the first letter, change it to this. Then you move to this letter, change it to that, move that, start writing this. And he had an infinite whiteboard that you could just keep writing letters and moving left and right. So that's what a Turing machine is. So let's just finish this lecture by seeing a couple more examples. Okay, here is a Turing machine for the language palindrome. And this is how it works. It's going to take the very first letter at the beginning and change it to a blank. Now this is really important because remember, we don't want to move our tape head off the left edge of this tape. So not only are we erasing the first letter, but we'll also putting a marker on our tape, a blank, so that we don't fall off the left edge of the machine. Then you can see in this state, we move across all of our letters until we hit a blank on the end and then we bounce back. Now we verify that this is the same as the first letter we read right here. So we read an A to start this, so we're going to make sure that we read an A to finish the word. We replace that with a blank. Then we move back across all our letters and until we find the blank at the beginning that was changed. And that's in this case right here, we're moving across all our letters. As soon as we find a blank at the beginning, we bounce off of it, and now we're pointing to the second letter, and we're in the start state again. So we keep doing that. We erase the B, go to the end. This is already erased. Make sure that there's a B there. Come back, erase this B, make sure that B's there. And now we're in the start state. And in the start state, if we read an A right here, we're not going to move over it, but we're going to immediately run into the blank. And in that case, we just check to make sure that there aren't any letters. So this is how we handle odd palindrome, is if we read a letter that doesn't have anybody that matches them in the middle, then we just make sure there are no blanks next to them and we halt. And then in this case, right here is for the B. Now we also go to a halt. If there wasn't this middle letter in here, we'd erase this B, move over, erase this B, come back, find that we're at a blank, and then in the start state, we automatically halt. So that's how this palindrome language works, is basically erasing and erasing. Now let's just show you one more for the language A to the N, B to the N, A to the N. Now you can look at this. What it does is it erases the first A with a star or an asterisk, and then it moves right past all the A's, moves right past all the B's, bounces off of this A right here. Here's the bounce off. Here's it moving right across all A's, moving right. So here's right across all A's, right across all B's, bounce off of the last A, come back this way, and then it's like replace this B with an A. That's this. So yes, it replaces that B with an A. Then it moves past all the A's until it hits the blank at the end. That's this part. Then it erases two A's. Here's the first, this is the bouncing off. Here's erasing the first A and erasing the second A. So we turn one B into an A, and then we erase two A's from the word. Then we rewind the tape until we hit that asterisk at the beginning. We bounce off of it and we do it again. We change the second A to an asterisk. The second B turns into an A, and then we erase two A's off of the end of the word and rewind and go back forward. Now that's just one way to do A to the M, B to the N. Another way could be to erase this A, turn a B into a capital letter, go to the end, erase that A, and then rewind, erase that A, change the second B to a capital letter, erase that A, rewind, erase this A, change that B to a capital letter, move across all the B's, erase that one, and then when we move back and see that this is a capital B, we just make sure there are no lowercase b's left in there. We also will need to check to make sure there aren't any lowercase a's in there, and then we can accept the word. Now, another thing that we can do is we can actually accept a to the n, b to the n, or a to the n, b to the n, a to the n, b to the n by just doing that one more time. And in fact, there's no limit. We can keep doing a to the n, b to the n, a to the n, b to the n, a to the n, b to the n, however we want. We can always create a Turing machine to accept words of that kind of format. So that's where I'll leave this lecture. You might want to go to the book. This is described in more detail on page 448 and 489 in your book. And now, again, the two things that you have to do with these Turing machines is be able to look at one and figure out what language it accepts. And then if we give you a language, you'll have to be able to create it. Now, to save us time a lot in this class, instead of actually drawing down all the states, it actually becomes easier to describe what the Turing machine does to its input tape. Kind of like move to the beginning of the tape, bounce off of this marker, change this letter to that, then move to the end of the tape, bounce off of that marker, change this letter to that, and so on. So usually these Turing machines, instead of drawing them out right here, and you can probably tell it's a little hard to describe what a Turing machine does from a picture like this. Instead, they just describe what the Turing machine does. So we'll end up doing that a lot in the next few lectures.